You're listening to Data Center Therapy. Please take a number and an engineer will be right with you.
Hello, everyone, and welcome to Data Center Therapy, a podcast by Ivoxy Consulting that talks all things IT with a healthy dose of empathy. I'm your host, Matt, the other Matt, Yeti, and alongside me is my co-host, Matt Cozzolino.
What's my AS number?
Each episode we dive into the wide range of technologies that make up this beautiful sandbox called IT that we all play in. We share our hopes and dreams, opinions both positive and critical alike, all with a touch of empathy because at the end of the day, we all need a seat on that couch. Before we get into the topic and our special guest, we wanted to remind you of some events we have coming up, namely our actually wildly popular virtual workshops. In June and July, so the end of this month and next month, we will be doing virtual workshops on data center compliance. Now, it's not everybody's favorite subject. It's kind of like the new backup, I feel. Where backup is cool now because there are some awesome products, but now we're in these compliance, SOX, HIPAA.
Everyone cares about security now, huh?
Right. Well, you have to, right? And it's really kind of complex.
It is.
and right, and keeping up on that. So we're doing our best to help you out and kind of break it down and simplify and explaining how we can help. So some data center compliance workshops will be going on this month and next, and as well as in July, network automation, which we have one of our amazing network engineers here with us to maybe dip into that a little bit later, but to check out information on those workshops coming up, go to ivoxy.com/virtual-workshops. ivoxy.com/virtual-workshops. Okay. We have a very special guest with us today. He's been with Ivoxy. Well, I'll let him tell you. But his name is Keith Emmanuel, and he is an absolute network savant. Pardon me for saying so, Keith. But he's joining us all the way from Boston, Massachusetts. Don't hold that against him. I will hold it against him for you. But good morning, Keith. How are you?
Good. How are you? I see.
Good.
I see. We don't have many Pats fans in the house right now.
Well, as a native New Yorker, and not the city, but still, as a long-suffering Jets fan, it was interesting to hear you forget that who are the Patriots? Who's Tom Brady? All of a sudden, you know, that fandom goes out the window. So,
I don't know. The Red Sox have lost for a long time, and we still got a lot of fans out here. So,
All right, I'll take it. Anyway, Keith, tell us about yourself a little bit, personally, professionally. How'd you get to where you are right now?
I've been working as a network engineer for the last 10 years or so. Originally on the customer side of the house, so working for startups in the area, working for a defense contractor, going through a couple acquisitions, things like that. And then when I moved to Seattle, I switched over to the VAR side. So working with another VAR in the area before eventually coming over to Ivoxy for about the last year and a half. So playing both sides.
A year and a half. It's only been a year and a half. Wow.
I know, right?
You fit so well with us. It's great.
So, and one thing you did not mention that I want to make sure everyone knows, and you're a little humble for it, but you are a CCIE.
Yeah.
And yeah.
So
and is that one of the specializations? And pardon me for not being completely familiar, but I know there was like a CCIE voice and etc. Was there a tag on that, or is it the general CCIE?
So this one is CCIE route switch. So this is the
the core.
Yeah, the core one, the generalist. And so when I guess when I was starting out as a network engineer, I was using Cisco's Blueprint, their certifications as a stepping stone as to how to grow my skills. And I found a lot of value in that just because I wasn't getting that out of, my day-to-day job for the most part.
Is networking what you've always done in technology? You didn't spend any time as like a sysadmin and then say, hey, this network stuff's really cool, let me do that instead?
Actually, I spend more time as a programmer. Like I alternate between programming and network engineering. And so if I'm doing something technical, it will most likely be programming. If I'm doing anything sysadmin-y, it's to be able to get my programming environment up. So
okay, so that's why Python and everything's right up your alley.
Yeah.
That's why the automation stuff. Okay, that's cool. I didn't know that. Neat.
I didn't either, and I also like how you say that you took the generalist CCIE exam, and I guess that was my fault for leading you to classify it like that. But if there's anything not general in terms of general knowledge when networking, it's definitely a CCIE, right? It's like talk about
Yeah.
deep.
It's the deep end of the pool.
Yeah, yeah.
Yeah.
Well, that is cool. Well, one thing, the kind of the headlining topic we want to talk about, and obviously it has to do with networking, is BGP. Now, Mr. Cozzolino, I'm going to let you run with a lot of this only because, well, it's interesting. If you don't know this about Matt, Cozzo started as an ops guy, but on the system side of things, I would say. And Matt, correct me or step on me if I misinterpret here,
Nope,
misrepresent.
That's right.
But how long ago was this? Maybe what, 4 or 5 years ago? I
It was
think
about 4 or 5. Yeah, we had a need internally for some network teams, so I said I'll do that and decided to spend some time as a network guy.
Yeah, it was
I
basically if you do that, you need to basically ignore systems for a
Mhm.
while. Not that you have to lose your knowledge, but you're going to be focused on networking. And if I had to guess, I'm guessing for you personally and professionally, it was probably one of the most important things in your career up to this point.
For me there was two things. I did a CCNA class back in high school, college area, which laid a lot of groundwork, which I now look back on and I go, wow, that was super, super helpful. Um, but but yeah, there was a pretty good chunk of time where it was let me just focus on network. So I'm nowhere near as deep as Keith here, but
Sure.
I've been around the block and I can talk a lot of that high level stuff. For me, it ends up being mostly like data center layer 2, just a bit of layer 3. Once we get into big layer 3 stuff, I'm kind of out of my depth there.
But I've seen you also become more organized, and the networking mentality and mindset I think is kind of trickled down into your other skill sets in a good way. I find that you've got that network guy mentality without the hubris. Not yet, at least. No offense, Keith.
So roundabout way, BGP, right?
Yeah.
Yeah.
So I'll give you my understanding of it at risk of being a layman. So my operations guy attitude towards it is, why do I need that? I'm not an ISP. Isn't that just for big ISP peers? Maybe I'll dabble in some OSPF or EIGRP, but why do I even care about BGP? Is it something I need to care about?
So, is BGP something you need to care about? So you touched on a couple routing protocols. And so what is a routing protocol? Routing protocols are used to exchange routes, and routes or networks are essentially where your services and servers live. And so if you want to have like a web app or something like that, you give it an IP address that lives on a network, and you need to share that network in order for things to actually communicate with it. So within your organization, when you control all of the routers, you can run OSPF, you can run EIGRP. Those are two routing protocols that are commonly used within an organization. But when you start communicating with other organizations that you don't necessarily control, that's when you're going to have to use BGP. So BGP is the routing protocol of the internet effectively, and it's mainly used to exchange routes between organizations.
So it's kind of apt in the name there because BGP is Border Gateway Protocol, right? So when I've got my organization connecting to your organization, that's that border there, right?
Exactly.
Yeah.
And would me being company X with a site in Los Angeles and a site in New York, would that be two organizations, or would that be a single organization, or is it our favorite "it depends" answer?
It's definitely going to be it depends answer. So it depends on whether or not you have a similar routing policy for both sites. It depends on whether or not you're announcing the same prefixes from both sites. But regardless, you can use BGP at both sites, but I guess how you represent your organization to the rest of the internet can potentially change.
There's a term for the way the different routing protocols work. So like OSPF, EIGRP, I can plug a bunch of routers into a single network, and then they just learn about each other and share that information and share their routing information, right? Versus BGP, I have to actually like make a connection between this device and that device and be very specific about this
Is it
connection.
statically
like
defined?
I have to say I'm going to make a connection with you rather than here's this network where I have to meet stuff. What's that term? What's the difference between those two types of routing protocols?
Well, I think so. Your
I think
interior.
you're talking about autonomy, right? Or autonomous? Is that what you're getting at, Matt?
I think so. I mean, more the concept that I can have I can define a network and I can plug my 3 or 4 routers into it, right? I can do that with EIGRP for my closets, for my floors, for my whatever, right?
Right. So with BGP, you have to be intentional with how you set up the peerings. So when you have an adjacency between two routers, that's called a peering, and you have to statically define those. With OSPF, with EIGRP, RIP, all the other interior gateway routing protocols, they rely on multicast in terms of neighbor discovery and being able to determine the liveliness of the neighbors on the other side. And so that's how they're setting things up in that regard. But when you set up a BGP peering relationship between two routers, you have to say, this is router, I am router A, I am router B, and specify, whether or not you're the same organization or whether or not you're in different organizations.
How do you do that? What's that organization thing? How's that work?
So the organization thing is whether or not you're in the same autonomous system. And the autonomous system can be as big as your actual company, or it can be as small as maybe a router, or it could be somewhere in between, like a department. So the engineering department would get one autonomous system. Your data center might get a different autonomous system. Your internet edge might get a different autonomous system. And then, your holistic view of the environment is maybe like a mini internet if you were to go that route.
Okay, so it's not. Is it correct then that it's not just here's the networks that I own that I'm going to share with you?
So with the BGP information you share, you can also load the routes with metadata. And so every BGP route that gets advertised is going to have a list of BGP attributes that may or may not get advertised depending on the type of attribute it is. So things like local preference, if it's IBGP or AS path, or maybe a list of communities, things like that. So that will get advertised or relayed when you're advertising a route from one router to another router.
Is that then something? So with your programming and your automation chops and stuff like that, is that metadata something that then you can write rules on or write policy on and do something with, or is it more it has to be baked into vendors' implementation of BGP to be able to turn that knob and do something with it?
So that metadata, you're using that to write business policy. Like BGP is so the primary use case for BGP is going to be ISPs, right? And then if you want to connect to another company, because ISPs, they primarily have other customers, so they're interconnecting with a lot of different organizations. And then you, as as your one single organization, you might connect to only one ISP or two or multiple ones if you have a multi-homed environment. But how ISPs are generally set up is that they can have one of three relationships with another organization. They can either provide transit, which is reachability to the internet. They can be the customer of a transit provider, and then they can also be a peer. So if you're providing transit, you're selling a service. If you are a customer, you're purchasing a service. And if you are peering, you are exchanging services for free, effectively. There are paid peering arrangements, but for this discussion, let's just say it's free.
Okay. Peering would be something like I own a data center, and so I'm going to let these 4 ISPs have a presence in my data center and be able to peer with all of them so that I can provide connectivity to my clients, not necessarily paying.
If I could use a metaphor, I would say it's more like you have a saw. Matt Yeti has a hammer, and then sometimes when you need to use, if you wanted to use his hammer, you would be able to for free. And if you wanted to use your saw, something like that. So like,
well, that would have made that project way easier. I kept trying to get those nails in with the saw, and it just.
I have a nice hammer too, by the way. Yeah.
Yeah.
Okay.
But Matt's not charging you to use it, right?
Because we're buddies.
Yeah, and you're exchanging something of equal value effectively.
Okay.
And so
Okay.
if you're peering, you're effectively you're with a, let's say Verizon and AT&T, they have they'll have a peering relationship because they both have customers. They're exchanging a rough the same amount of traffic equivalently in both directions, and if I have to pay you $10 and then you have to pay me $10 right back just because we're exchanging traffic and we're purchasing bandwidth from each other, that's just a lot of frivolous, billing.
Paperwork, yeah. Okay. So primarily BGP for our internet connectivity, and I know it sounded like I want to say it's kind of a trivial, or not trivial, but arbitrary hard limit, but we can only advertise, like I can only advertise a /24 out onto the public internet, right?
Correct.
And that's specifically because all of the ISPs said, I'm only going to let you tell me about a /24, right?
Correct.
Okay. But that doesn't prevent us from doing anything smaller than that inside of a network, right? So I might actually have a use for BGP inside of my network, not just peering with the with an ISP.
Yeah, I mean, a lot of organizations use BGP within their environment. Some big web scale organizations, they use BGP for their data centers. So like Facebook, they released an RFC for how to structure BGP within your data center. Even the more trivial case, having an MPLS connection. Typically, the handoffs for that will be BGP.
Okay.
Because your MPLS provider is a different organization from you, and they're participating in routing of your networks.
Okay. So that actually, to me, brings up another thing. I've heard very often the difference between IGP and EGP. Is that the right way? The interior versus exterior.
Yes.
There is this a correct statement? There isn't any technical difference between interior and exterior other than I'm peering with a someone else, or I'm using this internal to my environment. Is that a true statement? Like, fundamentally, BGP is the same. I just happen to use it internally versus I happen to use it to my ISP.
Yes. At that point, it's more of a qualitative difference. So you're using it as an IGP if you were to use it internally.
Okay.
So as definitely low man on the totem pole as far as network experience, and when I talk to my customers, I take pride in being a well-rounded consultant. Where, in fact, the early part of my career, you look at my resume and my titles are all network related, and I kind of just kept getting pulled into systems, kept getting pulled. So I can do static routing. I can do a lot of layer 2. Kazo, it sounds very similar to what you described, but rest assured, Mr. Cozzolino is way deeper.
You keep coming to
than
me
I
for
am
questions, so hey.
At this point. Yeah, well, I come to you for affirmation. Is this right or is this wrong? And here comes a dissertation. But to that point, I don't deploy BGP ever, I guess is my point. That's an area level that I never touch. Obviously, I generally understand the concepts of it, but I don't have to really understand it. I got an awesome networking team for that. So, with that said, when I hear about BGP, in recent times, it's always, whoops, somebody advertised something, made a boo boo. So it sounds
I
to me like,
advertised your network over the internet, and now you can't get, no one can get to your stuff because they're coming to me for it or something like that, right?
or Russia or some state actor starts advertising networks that it doesn't own, and traffic gets redirected and therefore possibly sniffed through their pops at nefarious locations. It sounds like it's a simple protocol, in basic in terms of it does a very specific set of things, but there's not a whole lot of security behind it. There's a lot of trust, at least initially, kind of like SMTP. Hey, you're a mail server, I'm a mail server, here you go. And now we've kind of backfilled anti-spam solutions that are varyingly, successful. What is the problem, and is there a way to secure BGP, or are we kind of taking baby steps on that path?
So there are ways to secure BGP, but I would say they could be categorized as baby steps. But a lot of the problems that you have with BGP, I would consider, the most likely the option of poor practices and bad hygiene from an operational standpoint.
Kind of everybody has to play ball to make it effective.
Yeah. So it's if you got a couple ISPs that they aren't implementing best practices, they aren't filtering out the prefixes for the customers that they know that they have, then then your customer can effectively announce whatever networks that they want to, and that with IP address exhaustion, you can have you know spam organizations. They'll look for unused IP space on the internet, and then hijack those routes, announce them, set up a spam campaign, and then just give the route back afterwards.
Okay.
So we have some pretty high profile examples of BGP issues in the past, though, right? So, like, I'm looking at some notes you'd written down about YouTube being taken down by Pakistan, and we've got some Netflix drama between Level 3 and L3 and Comcast.
Yeah. So YouTube being taken down by Pakistan. So how the internet works is that, or how routing works in general, is that the router will always prefer the most specific network. And so,
what does that mean?
Okay, so when you have an IP address, you have two numbers that are typically given. You have an IP address, and then you have a subnet mask. Your IP address gives you the combination will give you the network that the host is on, in addition to what the host bits actually are. So the combination of those two things would tell you what network and what host on that network. So when you advertise a route, the one that has the smallest, the longest prefix is going to be the smallest network, which is the network with the smallest hosts, right? If I want to get to Washington State versus I want to get to Seattle versus I want to get to a specific bar in Capitol Hill, right? So you're going to pick the most specific information in order to make your determination as to where you want to go.
And you're going to want that information absolutely accurate, because you do not want to stumble into the wrong place in Capitol Hill right now.
Yes. I mean, are the bars open or closed?
I don't know.
So
you let me know if you're out there.
So that kind of goes to the idea that I don't have to know everything about that environment. I don't have to know how to navigate to Seattle, how to navigate around Seattle, because I know that once I get to Seattle, I can follow some more signs and do some more route lookups and figure out where I'm going once I get there, right? It's that kind of a thing?
It's more that, let's say you have 3 routes in your routing table. You have one for Washington, one for Seattle, and one for Capitol Hill. And so if you know you're going to Capitol Hill, you'll take the Capitol Hill route. If you know you're going to somewhere in Seattle, you'll take but not Capitol Hill, you'll take that more general route. But if you know you're going to Tacoma, you'll take the Washington State route, right? And so so depending on the specificity of the route, you'll take either you're always going to take the most specific route if that's where you're intending to go. And so what happened with Pakistan was they wanted to block YouTube or a couple specific servers, and what they should have done was just nail up a couple /32 routes, host routes that point to null zero, to drop the traffic. What they ended up doing was they advertised a /24 for YouTube, and that was re-advertised out to the rest of the internet. And so if YouTube was advertising a /22, that's the equivalent of advertising, the Seattle route. Pakistan was advertising the Capitol Hill route, and if everyone's trying to get to YouTube, they were trying to get into, they all got sent to Pakistan.
Who wins in a conflict? Like I've got two edge devices, internet connected devices that are leveraging BGP to advertise, hey, I own this /24, and then this other guy over there does the same thing.
It depends.
That's that hygiene piece, right? I mean, because at that point, YouTube's reliant on a bunch of ISPs to handle that, right? They can't solve it. I guess they could, though, right? They could start advertising a bunch of /24s instead. Right?
So if you have two /24s, the winner is going to be dependent on where you happen to be on the network, right? Because in terms of how BGP does its path selection, so let's say you have two equivalent networks. It's essentially a game of rocks, paper, scissors. And so a bunch of the attributes that we were talking about before, like local preference, AS path, maybe MED, multi-exit discriminator, all of those will get, not all of them, but there's effectively a hierarchy of what gets checked before something else. And if you don't touch anything, if you are a customer of another network, your ISP is probably going to send your traffic to the network that it provides transit for. Okay. So how ISPs prioritize traffic is they're going to send most of their traffic to customers versus peers versus transit, because the relationship is, if I have a customer and I send them traffic, I can bill them for it. If I have a peer and I can send traffic their way, that's not traffic I have to pay for that I would otherwise send over to my transit provider.
Okay.
So when an ISP has multiple customers, they generally mark the routes that the customers advertise as higher preference.
Okay. Because you want them to use your network so you can bill them for that traffic. That makes sense. Okay.
But under like if you weren't doing any of that, it would be dependent on where you happen to be on the network. So if Pakistan happens to be closer, you on the internet in the U.S., you're further away from Pakistan. You're closer to YouTube proper than you are Pakistan.
We didn't know we were going to talk geography on this podcast, did we?
Right.
Just in case you were wondering.
This is one of those things that I would love to. It would have to be timely, but it would be cool if, I mean, I don't want one of those things to happen again, but we should have you back on, Keith, when it comes time to when the next issue happens, and then we can do almost like a root cause analysis, post-mortem breakdown. I remember, well, Kazo, I know we share a colo now for a lot of our lab stuff that we do together, but before you were on board with it, I don't think we were doing it yet, and it was that we were at another data center. We hit the issue a few years back where the well, at least this particular router at the data center, there was an issue with the number of complete distributed routes in the BGP routing table going over like 512,000. Does this ring a bell to you, Keith?
Yes. So
it went over a number, and Cisco's, a lot of like the 6500 series routers only came with a certain amount of RAM, and they could only handle 500,000 routes or something like that. I want to say 512 something was in there, and at that point it exceeded that number, and the routers dumped, and there were a lot of outages throughout the internet. Does that ring a bell to you?
Yes. So the thing that that you have to remember about routers and switches effectively is that they're embedded systems, and so when you have when you have a route that needs to be programmed somewhere in memory, and typically that'll be stored in TCAM, so that's tertiary content addressable memory, and so when you when you your router will load the actual routes up that it learns in RAM, and then when it wants to forward it programs that in TCAM for efficient for efficient lookups effectively. So there's a finite limitation on that, and so when at least way back when, I'm not sure when this would have been, but there are a lot of 6500s probably still in production.
Yeah.
You know, when those systems were designed, they probably did not have a shelf life that would have predicted that they would have lasted this long, and so their limitations were good for you know, the internet at the time, but I don't think the engineers necessarily foresaw the exponential growth of it.
Right.
Yeah. It's one of those things that I like to liken it to SMTP because I've done an awful lot of mail service stuff in the past, and it just, you know, back when email started, how old is SMTP? 30, 40 years old now maybe. It was built with implicit trust because nobody knew what the internet was going to be. It just interoperability and connectivity was the main purpose, the drive behind it, and kind of maybe they thought about it. We'll worry about security or later. Why would anybody want to do that? Well, here we are, and so hopefully some of these, you know, hopefully some of these retroactive security measures can start taking effect because we've seen when things go down. I mean, T-Mobile just had a complete outage, not a complete outage, but a big outage on their voice network last week that you know, the FCC is looking into. I mean, these are critical communication systems, and I think every time a BGP issue happens, you kind of hear that, boy, you know, this is something that no one's really been pushing hard, or very few people, and it could come back to bite us if we don't address it soon.
Yeah, that's definitely something that I feel like security is definitely an afterthought until after you've been bitten, right? So it's and that
backups.
Yeah. Yep.
Yeah, ask the person who has a failed hard drive. They will. Oh, I'll back up from now on. Well, a lot of good that did you, just to let all that, you know, 50 gigs of pictures you just lost.
The horse is out of the barn. Let's close the doors.
Yeah.
Yeah.
Yep. So any salient wisdom to leave us with, Keith, as we wrap up here? And it's not Yankees suck either.
I mean that's that's a given, Matt. That's a given. So what I would say is that if you have an organization that's, you know, out on the internet, make sure that you are filtering out the routes that you think you're advertising. Make sure that you're filtering in the outs that you think you should be receiving. Maybe look into doing something like BGP RPKI and setting up ROAs, route origin authorization, so to secure your prefixes. If you have web services, make sure that you implement something called HTTP strict transport security, so that if your routes do get hijacked, you know, you'll get a cert error warning, and you can't really get rid of that unless you use like a new browser or incognito mode, something that doesn't have a save session if you've previously visited that website. And then if you're still concerned about you know, BGP hijacking, I would probably say look into something that does BGP probes, that looks to see whether or not there are changes in the global internet routing table with respect to your routes. So something like a product probably like Thousand Eyes would do that.
Yeah, that's what I was gonna say. Is that's one of those, isn't it?
Yeah.
Cisco just scooped them up, right?
They did. So I'm not surprised. I'm not pushing it.
Yeah.
But it does what it does.
Sure.
Yeah.
Okay.
Well, I'm sure. I fear we'll be having you on again to talk about the latest incident. Hopefully not too soon, and hopefully not too massive, but it's really good to have you on, Keith, and thanks for helping us dive into something that I mean, day to day, we kind of take for granted, right? And yet here it is, a protocol that basically, if it went away today, the internet itself would go with it at this point, right?
Exactly.
Yeah.
I mean, we
Yeah.
say that, but all of my sysadmins that are going to deploy NSX are going to need to touch some BGP stuff there. So
It's
That
not
is true.
it's not that bad. It's just
no, it isn't.
And if you need help, we have Keith.
Weird, huh?
Keith, thanks again for joining us, man.
Yep, happy to help.
And everybody out there, if you've got any questions, or have want to go deeper and want to get Keith on the whiteboard, of course, that is always something that we're happy to do, whether it's virtually right now in these days, or if you can meet in person. We all do the mask thing if we need to. All good. Again, don't forget to check out the show description and our blog page for more details on our upcoming virtual workshops. Subscribe to us on iTunes or Google Play or Spotify, anywhere good premium podcasts are found. Visit us at ivoxy.com as well for the blog site, show notes, everything. You want to reach out to us, podcast at ivoxy.com. For Mr. Coslino, I'm Mr. Yeti, and thank you very much for listening to Data Center Therapy. Have a great day, y'all.